Okay, so this is a probability question, and this week we'll be doing probability in more detail than we've done in the past, although we have covered it in previous weeks, somewhat, done some problems with them anyway. So we have two bowls, one with 5 blue marbles and 15 red marbles. The second has 10 blue and 20 red. And we're going to pick a marble at random from one of the bowls, but they're not going to be equally likely to choose the bowls. We're going to roll a regular 6-sided die, and if we roll a 1 or a 2, we're going to take a marble out of bowl 1, and if we roll a 3, 4, 5, or 6, we're going to take a marble from bowl 2. So the first question is, what happens if you roll a 2? What's the probability that we picked a blue marble? Well, if we roll a 2, then we're choosing from bowl 1, and bowl 1 has 5 blues and 15 reds, so that one's pretty easy. If we roll a 2, it comes out of bowl 1, and the chances that it's a blue marble are 5 out of 20, or 1/4. That one's pretty easy. Harder question, if you play the game, what's the probability that you pick a blue marble? And if you did pick a blue marble, problem C, how likely is it that it came from bowl 1? So to do this, maybe the best way is to imagine playing the game a whole bunch of times. And I'm going to start with 180. Where did 180 come from? Well, as you might guess, I sort of reverse engineered it. I knew what was going to happen. And you can play around and see what kinds of numbers you need in order to make everything work out evenly. But, you know, if you didn't, as long as you were content with fractions or decimals along the way, you'd still get the right answers and the same answers. Anyway, let's just see what happens when we play 180 times. So we start with 180 times. And since the probability of taking a marble out of bowl 1 is 1/3, that comes from rolling a 1 or a 2 on the 6-sided die. So probability of coming from bowl 1 is 1/3. So 60 times we'll take from bowl 1. And the other 120 times from bowl 2. Okay, so if we take marbles from bowl 1, if we did that 60 times, well, 1/4 of the time we're going to get a blue, and 3/4 we're going to get red. 1/4 of 60 is 15, so blue, 15, red, 45. In bowl 2, there are 20 red marbles and 10 blue marbles. In other words, 2/3 of the marbles are red, 1/3 are blue. So blue, 1/3 of 120 is 40. Red, 2/3 of 120 is 80. And if we'd started with some other number here, playing 100 times or 200 times, we might possibly get non-whole numbers here. We might get fractions or decimals, but as long as we left them there, we'd still end up with the right answers at the end. Okay, so now we're ready to answer question B. If you play the game, what's the probability that you picked a blue marble? Well, we have played the game 180 times, and we got blues 15 and 40, so for the answer to question B will be 55 out of 180. And we could reduce that too, but we won't. And then C, if you did get a blue marble, what's the probability that it came from bowl 1? Well, if we got a blue marble, then that means it was one of these 55 times. And of those 55 times, 15 of them came from bowl 1. So 15 out of 55, which is 3/11. So there we have it. Maybe the best way of doing problems like this is to make a tree diagram. The hard part, if you're trying to get whole numbers, is to figure out what this number should be. I wanted it to be a multiple of 30 and 20, since one of the bowls had 30 marbles and one had 20 marbles. And that takes care of it.